All right, this question is about the photoelectric effect. Photoelectric effect is basically when light enters a material and then kicks out electrons, or you can also go the way where electrons would leave the material, bounce back in, and produce light. Basically, it's like the interaction between electrons and light. So let's say we had a solar panel. Solar panels are very, like the way they work is they use this idea, light goes in and electricity comes out. So let's say we have a solar panel of some unknown material. The solar panel is hit by 250 nanometers light, which is ultraviolet light, like sunlight. It shines on this material and it produces an output voltage of 1 volt, which is not very good, but whatever. Determine the ionization energy or work function, as sometimes it's called, of this material. Well, you always use this equation, conservation of energy. Light energy is going in, and then you have two other energies on the output. You have work function and E times V. E times V is basically the kinetic energy of the electrons, which gives the object voltage. So the solar panel will have voltage because the electrons that leave are moving and they have energy. So there's this voltage energy or kinetic energy. There's ionization energy and there's light energy. Those three things go together in this equation. This is probably the most useful equation in quantum mechanics besides E equals mc squared. Now substituting things in, light energy is hc over wavelength, or lambda. Work function is just work function. And then E times V is the charge of an electron times voltage. Now in the problem, h is a constant, 6.63 times 10 to the minus 34. C is 3 times 10 to the 8th. Wavelength was 250 nanometers, so we have to convert that to meters. And the charge of the electron, E, is given by 1.6 times 10 to the minus 19 coulombs. The voltage in the problem is given as 1 volt. Now, sometimes you might not be given these variables. You might have to solve for some of these variables. H and C will always be given because those are constants, but maybe you have to solve for the wavelength. Maybe you have to solve for the voltage. This is also a given, the charge of the electron. Okay, so plug in those numbers into that equation right here. You have hc over wavelength minus the charged electron times voltage would equal ionization energy. You end up getting this very, very small value for ionization energy. Now you could convert this energy into electron volts, which is another way to measure energy. And the conversion for that is that there's 1.6 times 10 to the minus 19 joules in 1 electron volt. You get that from an equation of E times V equals energy. But anyway, so just know that there's this many joules in 1 electron volts. So what you do is you take this many joules, divide by that 1.6 times 10 to the minus 19 conversion factor, and then you get 3.98 electron volts. So just to kind of give you a reference, when you're looking at these, your frequencies that you calculate will always be really big, like 10 to the 14th, 10 to the 15th hertz. Your joules will always be really small, like 10 to the minus 19th, 10 to the minus 20. Your EVs will always, your electron volts will always kind of be in the ballpark of like 1 to 5 electron volts. And your voltages will also be in that value of 1 to 5. So hopefully that helps. Have a good day.